Now that we talked about the Laplace transformation, let us introduce gamma function. Gamma function is defined as gamma of alpha, which is equal to the improper integral 0 to infinity of t to power alpha minus 1 e to power negative t dt, assuming that alpha is positive. This is used in Bessel functions. We want to show that the gamma of alpha plus 1 is equal to alpha times gamma of alpha. In a special case, if alpha is a positive integer, then the gamma of n plus 1 is equal to n factorial. So let us begin the work. Let me change a color. So by definition, we have a definite improper integral, and we can use the limit and take the limit of the definite integral and continue the process. By definition, the gamma of alpha plus 1 is equal to the improper integral 0 to infinity t to power alpha minus 1 plus 1 e to power negative t dt. So the gamma of alpha plus 1 is the improper integral of 0 to infinity of t to power alpha e to power negative t dt. We can use integration by parts. Let us take u to be t to power alpha, and then let me change the color, and dv to be e to power negative t dt. So du is equal to alpha t to power alpha minus 1 dt, and v is the integral of e to power negative t dt. So v becomes negative e to power negative t. So let us go back to our integral. The gamma of alpha plus 1 is equal to uv, which is t to power alpha, times negative e to power negative t minus the integral of v du, negative e to power negative t, and du is alpha e t to power alpha minus 1 dt. So let me just put this one in a box to avoid any confusion. Very good. Let's continue the process. The gamma of alpha plus 1 is equal to negative e to power negative t, t to power alpha plus. Basically here you have alpha, you can write alpha in front of the integral of e to power negative t, and t to power alpha minus 1 dt. But take a look. This is basically the definition of gamma of alpha. We define gamma of alpha this way. We say that it is the improper integral of t to power alpha minus 1, which is just right here, and then e to power negative t, which is just right here. So by definition, this can be replaced here. 0 to infinity. We're going to calculate the limit later. Don't worry about that portion. So the gamma of alpha plus 1 is equal to, here if you write this as t to power alpha divided by e to power negative t, put the negative in front of t to power alpha, where t ranges between 0 to infinity. And please note that alpha is positive. Plus, here you have alpha multiplied by the gamma of alpha. But if you plug in infinity here, this guy should be a positive sign because it put it on the denominator. So if you plug in alpha here, e to power t goes to infinity much faster than t to power alpha. And if you plug in 0, it is going to be 0. So this quantity is 0. So we just showed that the gamma of alpha plus 1 is equal to alpha times gamma of alpha. We showed the relation for the gamma function. One important note for you. If we change the variable u to be equals to s times t, then we get the generalized definition of the Laplace of t to power alpha, which is gamma of alpha plus 1 divided by s to power alpha plus 1 when alpha is more than negative 1. One important notation is that the gamma of a half is equal to square root of pi. So we're going to use this and calculate the Laplace of the following functions. Suppose I ask you to calculate the Laplace of t to power negative a half. In that case, following the formula, wherever we see alpha, we're going to use negative a half. This can be written as the gamma of negative a half plus 1 divided by s to power negative a half plus 1. So on the numerator, you get gamma of a half divided by s to power a half. Or you get square root of pi divided by square root of s. So you have square root of pi over s. Now suppose I ask you to calculate the Laplace of t to power a half. Well, by following the formula, this is the gamma of a half plus 1 divided by s to power a half plus 1. Remember from the formula up here, the gamma of alpha plus 1 is alpha times gamma of alpha. So if I ask you to calculate the gamma of 1 plus a half, this is a half times gamma of a half, which is a half times square root of pi. So let us use this important piece of information and continue the calculation down here. So this is going to be a half times square root of pi divided by s to power 3 halves. Or simplified as square root of pi divided by 2 times s times square root of s. We can continue this process and come up with more important formulas. For example, suppose I ask you to calculate the Laplace of t to power 3 halves. This can be written as the gamma of 3 halves plus 1 divided by s to power 3 halves plus 1. This can be written as 3 halves times the gamma of 3 halves divided by s to power 5 halves. And the gamma of 3 halves, which is 1 plus a half, can be calculated as, so here you have 3 halves times gamma of 1 plus a half divided by s to power 5 over 2, or 3 divided by 2 times a half gamma of a half divided by s to power 5 halves. Well, we already calculated the gamma of a half plus 1. This is square root of pi divided by 2. So this can be written as 3 halves times square root of pi divided by 2, or 3 times square root of pi divided by 4 times s to power 5 over 2. We can make it more interesting. Suppose I ask you to calculate the linear combination here. You want to calculate the Laplace of 2 times t to power a half plus 8 times t to power 5 halves. So let us start the process by linearity. We can write this as 2 times the Laplace of t to power a half plus 8 times the Laplace of t to power 5 halves. And continue this process using the formula that we just introduced. So I'm going to just copy down the formula for you here. So you can use this as your reference. And let me put that in a nice box. So let's continue the process, everybody. Here you have 2 times the gamma of 1 plus a half divided by s2 a half plus 1, or 1 plus a half, it doesn't matter what are you using here, plus 8 times the Laplace of t to power 5 over 2, which can be written as the Laplace of 1 plus 5 over 2 divided by s to power 1 plus 5 over 2. Again, by using the definition, we are going up here and using the definition of Laplace of alpha plus 1. Okay, let me put that one here as well on the other side. And then continue this process for you. So here you have 2 times gamma of 1 plus a half, which is a half times gamma of a half divided by s to power 3 halves plus 8 times. Now here you have 5 over 2 times gamma of 5 over 2 divided by s to power 7 over 2. And you're going to continue this process. 5 over 2 can be written 1 plus 3 divided by 2. And then you can break it down further. So you get 2 times a half. We can cancel these 2 out. And the gamma of a half, as you remember, we calculated this just right here, square root of pi. Let me put this one here as well and put it in a box. So this can be written as square root of pi divided by s to power 3 halves plus, we can simplify this to 4 times 5, 20. And then you have the gamma of 1 plus 3 halves divided by s to power 7 over 2, which can be written as, so for the first quantity, you have just the square root of pi divided by s to power 3 halves plus 20. Now here you have 3 halves times gamma of 3 halves divided by s to power 7 over 2. Continue the process again. You could also simplify this as 30. So I have square root of pi divided by s to power 3 halves plus 30 times the gamma of 1 plus a half divided by s to power 7 over 2, which can be written as square root of pi divided by s to power 3 halves plus 30 times a half gamma of a half over s to power 7 over 2. And in our last step, here you have, change this, square root of pi divided by s to power 3 halves plus, here you have 15. And as you remember, the gamma of a half is just square root of pi. So you can just copy down here, square root of pi divided by s to power 7 halves. So you can leave it like this or simplify it as much as you can. You can factor out square root of pi and you get 1 divided by s to power 3 halves plus 15 divided by s to power 7 halves. Or basically leave it as it is. Either is fine.